Hey guys, so I'm back. Well, I have to turn down the sound here. Okay, so let's see what's happening here with this project since the last time I did a stream. So I've been lately been working quite a bit with my input system because once I started to dive deep in what was going on with my memory management, I found a few problems that had carried over from my previous version of this project. So I've been cleaning that up. So I'm quite happy now. I have down to pretty much zero memory allocations for pretty much everything during the gameplay, which I'm quite pleased with. It's going to be helpful for more weaker devices like older Android phones. So it's going to play fine there. So while I was doing that, I also decided that I'm going to replace my HUD that's currently done with Canvas to use UI Toolkit. And the reason I used Canvas from the beginning is because I'm doing a few things that you couldn't really do with UI Toolkit. But after digging a little bit more, I found a few ways to do the last remaining things that wasn't really possible up until now, or until recently. One thing is masking with custom shapes. Out of the box, UI Toolkit only mask rectangular shapes, while Canvas can mask any shape, but I found a way to do that. So that means I can bring my radar system into UI Toolkit. And the other thing was memory-free or allocation-free strings, which I did a brief test on before, and I also figured out a way to do that. Because with Canvas and TextMesh Pro, you have a set char feature function in TextMesh Pro where you can pass in an array of characters instead of a string, so you can make allocation-free updates of text on your screen. Something that UI Toolkit does not have. But I was thinking a little bit, and I'm pretty sure I can make it work there anyway. And I did a very, very brief test by modifying a string in memory directly. And you're not really allowed to do that in C# because strings are immutable. But I think it's fine in this case. And it really helps because, for instance, I have my score here that updates frequently, and I don't want to cause a new memory allocation every time the score updates, for instance. And there are a few other places too. So I was thinking I'm going to do a custom visual element that can draw text on screen without creating any allocations. And I'm going to do it pretty specific for this project, but I'm sure I can expand upon it if it works fine to be more universal if I need to, or maybe you can get some ideas. Depending on this turnout, of course, I'm not really sure yet. But right now, let's see if I build the game now. It should be pretty much allocation free once it's warmed up. So let's just build the Mac version here. And this is going to be a debug version, so it has a little bit overhead, but I'm sure it's going to be fine. Just to see where we are at. So And actually, I probably should run this in a window. Let's see, project settings. Because it's built into full screen, which not really video friendly if you want to see the profiler at the same time. So, see if I can remember. It should be here, right? Full screen. Let's just do a windowed. And let's make it smaller. I bet that should work. So let's rebuild it. So I was thinking I should replace the score counter here first, and once that element is working, I can probably adapt it to more places. So let's see here. So here is the build. Let's see what we get here. It should be a window now. Well, they have very small, but that should be okay. So how do we it where? Make this one a bit smaller maybe. And there we go. And there we go. Bring it back. And we have the profile connected. So let's start the game. So if you are familiar with the profiler, here you can see the garbage collector's allocations, and currently it's pretty much 0 on every frame because I run it. Well, you got an allocation now because we went into pause mode, but it should be 0 here if I pause it. And let's bring this one up here. So here we have allocated in frame 0 bytes. So we pretty much here stay at 0 allocations constantly, and I want to keep it that way. So if I start here again, we're going to have probably a few initial allocations just while pretty much no allocation now. It keeps being a straight line down here. So and there we got one. There are a few places where something happening for the first time where it has to do one initial allocation, but it holds on to those, so it never happens again. So you can pretty much play an entire level without any new memory being allocated during the gameplay. So, and switching to UI Toolkit instead of using the canvas system, I don't want to lose that possibility to keep also the text display allocation free. Otherwise, it's gonna hammer a few. I think it's like 128 bytes or something, or 140 bytes even every time a small string like this updates. And if it keeps doing that 60 frames per second, it quickly adds up. And because right now I don't even flash the garbage collector while playing, just to keep it as fast as possible. I do it. I've turned off all those features just to get all the speed back to the game. So anyway, so let's see what we can implement here. So I set this my goal for these sessions to be 1 hour, and my goal is that I pretty much just start up where I am. This is raw coding or graphics, whatever I'm doing. So it's just going to be a view into my workflow for about an hour at a time, and sometimes run into problems that take me hours to fix, and if that happens, it's going to be quite a boring session. But I'm trying to start up the stream when I'm doing something that I think will not be that problematic anyway. So let's see where we are at. So I has began here. So I have my old HUD here that's just tons of game objects getting laid out here to build everything. And that's going to be nice to get rid of all these and just get it down to one object to hold everything as a UI document. So this is the current canvas HUD, and if I zoom out, it's this one. Not this one. This is my on-screen profiler that's on a separate canvas. And actually, if this works out, I'm going to also change this one to using UI Toolkit 2, because then I can bind the metrics and have it allocation free, which will make this way more easier to maintain. So anyway, this is the one, and the new one I just set up before a UI document. I have started a little bit this morning to create a new document. I pretty much just added my safe area container to play nice with mobiles, and 3 columns, one left, one middle, and one right. That's got to contain the same elements eventually, as I've converted it to UI Toolkit. And the red squares are just my placeholders to make sure that the safe area container works as intended, because I made a few tweaks to this element too. So there we have it. So let's make a new element. And we're going to call this one, let's see here, label. Label, I think Unity likes to call their own non-allocation stuff, like physics non-alloc, raycast non-alloc. So, similar, right? Label non-alloc. And it's going to be a visual element. It's going to be an UXML element. We're going to need a constructor. It has to be public, and it has to be partial. And that should be it. We should have a label non-alloc here. If we go back into the UI builder, let it compile. And it compiles. Right. So let's open this up and let's stock it. Okay, so I have to go back and forth a few times. So I'm gonna add this new element just below this red box. So there we have it. Label non-alloc. So in case you haven't made your own visual elements, you have the native one that Unity has out of the box on the standard, and then you have your own. Tab view tab button is something Unity has added themselves, but under here it's quite recent. I don't know why they're there. I believe they're gonna disappear before Unity 6 is out of preview. But otherwise, your own custom elements end up here, and use your namespace bitbebop UI element, and then the class name. That's how the elements, and then the class name here. That's how they come up here. And sometimes I name them control. Let's not do that. This is just a display, so I'm gonna drag this one up. Want to come up. I get some error, values are not equal. I get more errors, something from my aspect ratio class. I was working on that one before. The red ones are red file names here are classes that are not checked into version control yet. Okay, I don't really know what I did here. It seems to... And there we go. Now let's see. Can I now drag this one up? I can. So we have our new label element here, and it does absolutely nothing so far. But we're going to save this document because now we have an element here to work with. And I'm not going to change any settings here for now. What we might want to do is to use maybe the font asset here, or we can set our own up here, but might be convenient to just use the one here, because then we might be able to borrow from a style sheet. Let's see, let's just first get this working without allocations. So if I were to make a standard label, let's just get some something in here to display. So I'm gonna piggyback on my head manager, or my to be head manager, because it's empty now because I don't pass in any data yet. And if I change this to UI Toolkit, which I'm gonna do if this works, I will probably use the new runtime bindings to automatically update data, but one thing at a time. So first, let's just get the reference so the HUD manager is on my old HUD canvas class here, and here is the new HUD UI Toolkit. So we're gonna grab a reference here to the UI document, and we're gonna need a reference to our label non-alloc that we just created. Label non-alloc, and let's call this score label. That should be it. Now we can first inject the UI document here once it has compiled. There we go. So let's drop that in there. So now we have a reference, and let's then just grab a reference to the label we put into that document. For label, and that's going to use UI documents root, and there we're going to query for a label non-alloc, right? So there we have a reference to our new label. And what I want to do here is also to set some text, and it's going to be numbers, and I'm going to keep it simple and only allowing numbers right now. So we're going to set text, and we take an integer then. This has a return type too. So now we can set the text, and let's just go back here, and every frame we can just take our score label, set text, and we how about frame count? So we get a new increasing number every frame. Right. So first, just to compare where we are starting and see where we want to end up, is that we can probably just create the ordinary Unity out of the box label here. Right, and I will do some label, new label. And let's see, so this one show up. we set some text here. Right. And compile. I might have to restart Unity. So we didn't get any text, but because I didn't attach it, would be a good idea, right? So we have this add. Which one is that? Let me just see what matter. We do have to look for it. We do my slider, my spinner, add. That's it. Didn't see add. Oh, there it was. Some label. There, I think I see it already, but it's black. It's there, but extremely tiny. So let's, first of all, let's just start up quite fast, because it's so slow and just need to be refreshed. And while that one starts up, we can see we have some bigger. Let's hope it goes. There it is, way bigger. And could you set some color, text color, font color, color, fast. Let's do a chocolate. Could not. It want to have a style color, I think it was. And there we can do a color. That's gonna be easy to see. So anyway, there we have it. And let me take the value we got here. Some label, text, value. So this is going to be a lot of allocations now, because first we convert the string here, and then also I'm pretty sure the label also modify. No, it doesn't do that. This is where we get the allocation. And if you were to look at them, were to decompile, if we were to decompile this class, there simply is no way to pass in anything else than strings here. It cannot take characters, it cannot take arrays. It actually is a child of this class here. And I checked this some time ago, and there is really no way to put in anything here that wouldn't allocate memory. So that's why we're going to have to skip this one and draw our own text. So if let me turn off the back stuff I had here. This we can turn off, and we can turn off my on-screen profiler too, and my touch controller. So if I now build this game again, let's just see here. So now we have this count up here, where we change the value of the text string every frame. So if I were to build this game now and profile it, we should get a memory allocation on every frame. That's very quickly gonna fill up the garbage collector reserved memory. So we have a build, and we have our game in this very small window. So far no allocations here, just a little bit when I build the new panels. So here we go. So now we have constant garbage building up here. So if I were to pause this now and we check here a single frame, we have around 30 bytes per frame. Okay, it's not terrible, but it adds up if I have, this is just one element, right? So if I have a few more, then we quickly have a few hundred bytes per frame. And the goal here is to get down to 0. So if I were to check here, so we have the garbage allocation happening here. So it's right now in the HUD manager, and now I didn't have call stack enabled, but this is going to eventually end up in the visual element where we do the toString. So to get rid of this 30 bytes per frame, which would add up to 310 frames times 60. Very bad at math in my head these days. Times 6, I guess. 1.8 kilobyte per second. So and times number of text fields, of course. So if you have a lot of text fields, can quickly be 10, 20 kilobyte per second. It keeps adding up. So let's try to fix that. Make this allocation free. So that was the standard implementation. If you were to do this using the built-in visual elements, hopefully. So in the old Text Mesh Pro, you could do like this, some label text, then pass in a char array here, and then you did it allocation free. And I was kind of hoping that Unity would keep the new system on parity with this old, so you would have a set text here as an option to only text, so you could put it in allocation free here too, and maybe that will come in a future update, but things move slowly. It can take years before that is here, and I need something that works right now and that I can use until eventually, hopefully, they have it built in out of the box. So what we're going to do then is we're going to remove this text here, and instead this one we're going to keep, but we're going to start drawing our own text. We're going to do a generate, hook into this one, it should content, and there we go. So here we can draw our own mesh or our own vectors or our own text. I don't like this one, feels better. So we have draw text, right? And this one want to have a string. And what we can do here is that we take print. We take private string text. So we take this value we get in here, and we're gonna put that in here. Take text value. So first we're still gonna have allocations, but so we need a position. Let's go with the 0. We need a font size 42. So it's a good choice. Make it red. And we need a font asset. And we can keep it at the default font for now. So if we were to go back now to our game, so now it builds way faster than before, so restarting helped. Okay, so there we're drawing our own text directly on the mesh using the text core engine of Unity. And if we now were to use, and for it to actually redraw, once we want it to redraw, we have to mark this as 30, so it repaints it. So now it should look pretty much the same as before. And we should still get allocations. Can do a quick build and just try that. And there we go. Let's start it up. Let's take the profiler here. Start the recording. Okay. So we have the counter here. And I can already see these two are no lines at the bottom anymore, but are most likely constantly generating allocation on each and every frame. So let's stop the recording and let's close the game. So we have the same, it's the same 30 bytes that get reserved on, gets allocated, on every single frame, and it's this string here, and there's simply no way around it if using strings like this. So what we're going to do to avoid this, because we cannot, every time we update this string here, it creates a new string object, because strings are immutable in C#. So you cannot modify an existing string, it has to create a new string. String builder is one way to deal with it, but at the end of every string builder you still have to call two strings, so you can reduce memory allocations if you manipulate the string many times, but you're still going to allocate some memory at the end. And we want to allocate 0 memory every single time, so we allocate one string and that's it. We have to hack us around the immutable state. And there are two ways to do that. We can manipulate memory directly. And if you want to do that, we're going to have to write unsafe code. And if you want to write unsafe code in C#, you actually have to allow unsafe code in your assembly. But I don't want to go that far. So I'm not going to choose this way to do it. So we're going to keep the code safe, and instead we're going to manipulate our garbage collector, because the garbage collector knows what it is tracking. And as long as we hang on to this reference here, the garbage collector gonna have it, and it's not gonna remove it from memory because it's still in use. So we're gonna borrow the reference from the garbage collecting system and manipulate it that way. Or that's my plan. That's what I did an initial little test with before. When I did a very, very quick prototype just to see if it was even possible. And it looked good. So that's why I decided I'm going to try to actually implement it in a component and see if it can work out that way too. So what we want to do then, when we get the value here, so instead of having a string here, we're still gonna need a string, but let's call this string buffer. No, we're not gonna change this one. And I'm sure you can have some, we can set the size of it. Right, here we have char value start index length, value start. Character and count, that sounds good, right? So we set the char, can keep it empty, and let's have a buffer of 10. So that's going to be a limitation with this approach, that the text string going to have to stay within the size we say for the buffer, or we're going to have to reallocate a bigger buffer. So you can have a big buffer to have some extra space, or we could also have a buffer size. And we can expose, and we can expose this to the editor. String buffer and string buffer. So then we would in UI builder here, we're now going to have a buffer size here where we can set how big the buffer going to be. And then we could, instead of creating the buffer here, we create it here, right? String buffer new, and then we use buffer size. So then it becomes a little bit more flexible. So if you know we're going to need more characters, we can allocate more characters directly in the editor here. But I'm not going to do that yet. So I'm going to remove this and just keep it simple to get it working first. So now I have a string buffer, and this is the buffer we want to manipulate. So let's see if we can do that. So now we display this buffer, and that should of course be 0 allocations, because we take this one away here. This is going to be 0 allocation. We don't even have to try that. We know it's going to be 0 allocations. And of course, nothing also going to change, because just 10 spaces in this buffer. So we just have an empty space there right now. So what we want to try to do here now is see if we can manipulate that buffer. I do have a problem with that word, manipulate. Manipulate that buffer. And once that is working, we can transform this integer value we get in here to something we can put into that buffer without having to allocate new strings. So the approach then is to use the garbage collector. So it has a handle. So we have the GC and handle alloc. And here we can get the allocation of an object that we have. So we can do, it should be pinned weak. It's not a weak, it's pinned, right? So then we have our var handle, easy handle. So now we have a reference from the garbage collector where the string buffer is allocated in memory. And we can use this reference to get the actual pointer to the memory location. So we want to get the string address. I guess it's 2Ds in English, string address. Now we're going to get from the GC handle. What do we have here? GC handle. There, address of pinned object. And that should be it, right? So here we have a pointer, string pointer. Prefer pointer. Make it short. I used to be a fan of very short names, but I try to, with my age, I try to use longer and longer names, just so it's easier for me to remember what I did when I pick up the code. So now we have a pointer here, and we're going to need to clear this out too. So easy handle, and we had a free here once we are done. So here is where we can do the magic. So let's just try to set one value here, like the first letter, something, just so we see that we can actually manipulate this string every frame, hopefully without any memory allocations. So what we're going to do here, we're going to write directly to this address now, but we are still in safe mode. So the compiler should still give us some assurance that we're not doing anything too naughty to this system, right? So we have a, and here we're going to write in pointer and a character, right? So we have our pointer, and we can just set the character. Then we have an offset. Offset we're going to need once we start populating the entire string. But we can put in a value there. Now we can use the second one here. So I keep jumping between Windows and Mac, and I forget which shortcuts is where. So we want to use the second one, this one here, pointer, offset, and a character. That should be fine. String pointer, set an offset of 0, and let's just do it. A. And this should be it. Now we hopefully are manipulating this string without generating a new object. And by that, we do this allocation free. So let's start this. Okay, we have an A here. So that's looking good. Let's build it. So I never run the profiler. When I do optimization like this, if I start the game here and run the profiler, the editor is doing so much crap that has nothing to do with the game. So you cannot really see what's going on. But we can probably see that we don't have any allocations from that one. I don't know. We get some spikes here. It allocates 260 bytes memory every once in a while. That's probably, what can that be? Not even in the list because it's the editor doing it. But actually, what we can see here without making build, because is that we are not doing any allocations anymore. So the only time we have an allocation here is something that the game engine, the actual editor, is doing that will not end up in the actual build. But we are not producing any allocations because we are changing this to A every single frame. We have 0 allocations most frames. I don't even have to build it. We can see it already now that this is allocation free. So what we would like to do then is to grab this value here that we get in and convert it to chars. And then we can just iterate over those characters and update this string. So how is my time? 47 minutes. Oh my god, this is going way too fast. So, so what I'm gonna do, let's make a little conversion method here. Private. It can be int to char array. So what I'm gonna do now, I cannot return a char array here because then I have to do a new char, and that's gonna create an allocation for this new array. So we have to have a char array that we keep in memory, and this is because it's an array, this is mutable. We can replace the elements in this one and not going to allocate anything new. So we're just going to have like let's call this char buffer, and we're going to allocate the same length as the string. And if we were to have this setting like I showed before as an attribute that we can change an editor, we would use the same value for both of these because these two should match, because it's going to be the same length. So this is where we build the chars that we're going to have to eject, and this is where they end up. This is going to be a little bit more straightforward. We don't have to manipulate any memory or anything for that. So once we get the value here, we're going to pass in that value, an int, and we're going to pass in that char. And actually don't have to pass that in because it's already here. If I were to have multiple buffers, but we're going to make one wish element per label, so one element, one buffer, so I don't pass that in, I just pass in the value here. So one reason to pass it in could be just for clarity. So if you want to know where the result ends up, but I guess a comment could do that too. So once you pass in that here, this method here are supposed now to update this buffer up here. So this buffer gets filled with the values we are looking for. So we're going to have to deconstruct this integer into chars. And that's not too difficult because every character comes in that was not here, comes in order. So you can just offset from that. So first of all, if we have a value 0, you can try with that first. Then we set the buffer, and we're gonna have an index, because we're gonna have to iterate from position 0 to 9. So we start with the var index 0. So we set the char buffer index, and that's equal to 0, right? So far, so good. So what we're going to do then is that we can iterate for so we have the string buffer, the length, and then we can take this one here. So with in the offset, it's going to be the I value, and the character we put in is from the character buffer and at the I position. So this should most likely do it. And if I pass in value 0, and we don't want to return anything here, and we should actually get the character 0 now. And it should still be allocation free. Okay, so there we have a 0. So that's working fine. And so let's just continue here. So if that one we can do easy, but if it's not 0, then we have to actually do some, oh, scratch my leg. So we have a start index. This is kind of, if you have done this kind of converters before, it kind of follows this pattern here. You have a start index where we start counting, which is 0 here. So we could actually also just well write 0, but no, I was thinking we might want to pass in the index. We put it like this, because I'm not going to do that now. But if we do that, we can start to manipulate later in the string. Let's say we have a string of 100 characters. Then we maybe not need to manipulate the first 10 because they're always static. So we can always pass in an index of 10 and start there. But let's not do that now. And let's try to keep it simple. So we're going to do a for loop here, and now I see here I'm running very short of time. I said I was only going to do this 1 hour at a time, but I feel I'm so close now. I should probably just try to finish this anyway. So we want to iterate this value. Then we're gonna, so what we want to do here, because we want to get split it up in segments. So if we have the number 101, first we want to carry with the last digit, then the second digit, and then the third digit. And because the numeric system is based on the number 10, we can quite easily do that by just dividing, going in steps of 10. And by that, finding each segment. So we're gonna go through the segments here, and so let's go to the char buffer, and we're gonna take the index, and we're gonna increase the index for the next loop. So we're gonna go. So here we're at 0, and next time we're gonna be at 1, and so on. So we're gonna take a char, and we're gonna take the value, and we're gonna get the modulo for that one from 10, And depending on how many we're gonna also, this is right, so this we're gonna have to add like this, right? I think this should be it, but we're gonna have to do a little bit of casting here too. So this one is gonna be wrapped before we do this. Then we're gonna have to cast all this together. And I think that's it. We might have to do here too, sure. And oh, that looks okay. A lot of casting there, but I think this is okay. So here we get the number. Right, and then we're gonna do again. So here we have the index, start index, and I might have to optimize this a little bit once it's working, because I feel I have to code fast to try to keep this within an hour. So here we have a loop anyway. So we just want to keep looping through each 10 segment or each segment. So let's create the temporary buffer here where we can get the char. So we have the char, and that's going to be the char buffer. And then we're gonna char buffer, and we need the start index, char buffer, and we need the end index. And finally the value back here, right? And this should be it. So if I now pass in the value here, no, not really. Close enough. So let's see. I must have made some weird little bug here somewhere. So let's see here. So we have the index 0, and for 0 it worked. So that's the quick one. Then we get the start index from the index. And we have the value, and if the value is not equal to 0, as long as the value is not equal to 0, we keep dividing 10. Then we have the buffer, and we pick it up. 1, 1, 2, value, modulo 10. Right, and then we have the index. Oh, no, that's correct. Start index, all of them, end index. Then we keep going. And if start index and end, that looks fine. Start index, char buffer, start index, char buffer, end index, char buffer, end index 10. As far as I can see, this should work. So why isn't it working? Isn't that weird? I don't think I can print out the login array here, right? It's very close. This seems to be some. This is not our code. Oops. Very interesting. So what is going on here? So this one goes from that. Put the string pointer there from the char buffer. So the char buffer builds up. And Ooh, now I'm over my time. So should I try to fix this? Should I save this for next time, maybe? You never know, but it looks very correct to me. So what am I not seeing? But what we can try anyway is we can make a build and just see so we don't get an allocation so far. Maybe get up with an idea what's wrong while I do that. So, go. And let's start the profiler here. So apart from it showing the wrong character, we should most likely still have 0 allocations. So it keeps updating this string, and we don't seem to have completely 0 allocations too yet. So let's see here. Oops. Let's do a little bit here. Right. No, it looks quite okay, right? So let's see now. Let's stop here. No, so it's 0 byte allocation every frame. 0 byte allocation frame card 0. So it does behave allocation-wise. But we do have some problem here with code here with the conversion code from a value to the buffer. So let's see here. So go in there. I feel like I'm blind. I cannot see what I did wrong here, but it must have been something, right? Or it would most likely work. Oh well. So I'm not gonna sit here too long with this. So anyway, 5 minutes over the time I said I was going to do. So I'm actually going to call it quits here. I'm very close to how this is working. I have this allocation-free UI Toolkit component. So I'm gonna look a little bit into this, see where I did something wrong and fix that. And I'm gonna take a look at this tomorrow again. Most likely just a small little thing somewhere, and I'm just too blind to see it. It annoys me. It should be here and we should be done actually right now. But somewhere I am blind for some reason. So that's it with the stream, I suppose. So yeah, that's it for today. And let's see you in the next one.